Okay, Common Core Algebra 1, we are going to talk today about solving linear inequalities and even more particular, more specific, graphing a linear inequality and then shading the solution to the linear inequality. So to start, if we have a linear inequality, and maybe we should even go back and say linear inequality is going to be some equation with two variables, okay, which we have up here, two variables, and then it's going to be like an equation but uses the symbols less than, greater than, less than or equal to, or greater than or equal to. Okay, so it's a lot like stuff we had looked at before, but now we're going to have two variables instead of one, and we're going to graph that. So a solution to a linear inequality is a point that makes the linear inequality true, and we can test that by plugging in the solution and simplifying, and either it makes a true statement or a false statement, which means it is a solution or it is not a solution. An example of that, if I take the point -1, 2, and I want to know is it a solution to y is less than or equal to -2x plus 5, what I'm going to do is take my point and plug it in. So remember, this is an x and that's a y. So I change my y to 2, less than or equal to -2, and then I'm going to have -1 plus 5. So we want to see, is this a true statement? We need to simplify this side now. So our left side is 2. We can leave that alone. And if I do -2 times -1, I just get 2 plus 5. And so I'll end up with 2 is less than or equal to 7, which is a true statement. 2 is less than or equal to 7. So you would say, yes, -1, 2 is a solution. Okay, something that would not be a solution, suppose we had solved it and we had gotten that 10 is less than or equal to 7. Well, this is not a true statement, so therefore that point, whatever would lead to that, would not be a solution. Okay, in this case, we did have a solution though. So one more step, we've talked about how we can determine if something's a solution. Now we want to actually graph it. So we're going to graph it the same way that we've done in the past, what we just did in last chapter, which remember we had three ways. We talked about point slope form, which looked like that. We talked about slope intercept form, which looked like that, and then we also talked about standard form, which looks something like that. Okay, and each one had a slightly different way to graph them. Now we're going to graph them just like we did last chapter, so you're going to make sure you need to bring those notes every day. And then we have two options. If it is less than or equal to, we're going to use a dotted line or a dashed line, so it should look something like that. And if we can also have a solid line if it's got the equal to part to it. So an equal to part is going to give us some sort of solid line like that. And so we start by graphing either with a dashed or a solid line, and then we're going to choose a test point for a possible solution. Now the easiest one to choose is 0, 0. Plugging both those in, things are going to simplify really easy. But remember, we can only use this when it is not on the line. Okay, so if it's not on the line, you're going to definitely have to choose another point. So two things are going to happen. Either we're going to get a test point is true, which means we shade that side. So if the test point is on the right of the line, you shade that side if it's true. If the test point is on the right of the line and it's false, then you shade the other side, the left side of the line. So whether it's true or false determines whether you shade the same side or the opposite side. So an example here, y equals -2x plus 5. In this example, this is in y equals mx plus b form, which tells us we're going to start with our b value, our y-intercept, and then we're going to move to our slope, which I'm going to rewrite as rise over run, -2 over 1. So I put a point at 5. That's my y-intercept here. And then because my slope is -2 over 1, I come down to write 1. And now, because I have this symbol in the equals to piece, I am going to use a solid line. So I'm going to graph a line that goes through both of those points. Okay, so we did a solid line because it had equals to. We graphed our line. The next piece is to choose a test point. So I'm going to take the test point 0, 0 because that's not on my line, and I'm going to plug it in and check. So 0, 0, I want to know, is this a true statement? I'm going to plug in 0 is less than or equal to -2 times 0 plus 5. I just changed my x and my y in our given equation to 0, 0. Which, if we solve this, -2 times 0 is just 0, and 0 plus 5 gives us 5, which is a true statement. 0 is less than 5, which means everything to the left of this line should be shaded. Because this point is true, everything over here should be shaded. So we go ahead and shade this side just like that. And this gives us all possible solutions, meaning any point that I chose over here and plugged in would make a true statement. Okay, any point that I chose from over here on the right side and plugged it in would give a false statement. So true statements, false statements. Okay, and that's really it for this lesson. We talked about how to graph a linear inequality. It's essentially the same idea as graphing a line from last chapter, except for now we have that extra thing with whether it's a dotted or dashed or a solid line. And then we're going to shade one side based off of if a test point gives a true solution or not. See you next time.